Hi, welcome to EC&M Tech Talks. This is a series of how-to videos where we cover everything from basic theory and how some of our equipment and devices work to those individual equipment and devices that we install out in the field, as well as we move through some of the codes and standards that apply to the installation and maintenance and operation of our equipment. And that's just where we're headed today, as you'll see. Anyway, this series of how-to videos, Tech Talk videos, is brought to you by EC&M Magazine. That's Electrical Construction and Maintenance Magazine. And so what you need to do is, if you haven't already, you go to ecmweb.com, ecmweb.com, and then you look on the upper left-hand corner and there's a drop-down menu. That very first item that drops down in that menu is called premium content. And that's what you want to do. You want to go to where it says premium content. And if you haven't already, go ahead and sign up for premium content. Why? Well, a couple different reasons. First of all, it's free, so you might as well get it. And also, it's going to provide you a lot of information, not only on today's Tech Talk, but other electrical items that certainly affect us out there in the field. You'll find different media types, videos, articles, and so forth. So make sure you sign up for that premium content then at ecmweb.com. I'm Randy Barnett, and I'll be your facilitator today. My background is I'm a journeyman electrician by trade. I started a long time ago back in the Navy and worked as a journeyman electrician, primarily industrial work then. Since become a certified electrical inspector, and I've done some electrical inspecting for different companies. I also am a certified electrical safety compliance professional through the NFPA. I write textbooks and so forth. And here I am today then, right? And today what we're talking about, what I said we're going to have some fun with today, is the NFPA 79 standard. NFPA 79 is the electrical standard for industrial machinery. And between you and me, I think this standard gets forgotten a lot. We pay a lot of attention to, NFPA 70, which is the National Electrical Code. We pay a lot of attention to NFPA 70E, which is our standard for electrical safety in the workplace. If you work in healthcare facilities, you may be paying attention to NFPA 99 regarding healthcare facilities. If you work with fire alarms, you may be, you certainly work a lot with NFPA 72 for our fire alarm code and so forth. So anyway, NFPA 79 is the standard for industrial electrical machinery. And the latest edition is the 2021 edition. So we're going to go through this today and we're going to see how it applies to us out in the field. Now, you say, well, Randy, we already, we have information in the National Electrical Code. We're just going to follow the code requirements then. And that's true. You are. You're going to follow the code requirements all the way up to the supply of the industrial machinery. Then, after you reach the supply, the disconnecting means, whatever type you have, from there on in, NFPA 79 is going to apply. So that's what we want to go through, some of this in NFPA 79. Now, I'll tell you another thing as well, right? In your National Electrical Code, you can look it up, but it says that the National Electrical Code does not apply to the internal wiring of equipment, controls, machinery, and so forth that you would purchase. However, if you're going to modify that wiring on the inside, then the NEC requirements would start to take effect. So we're going to look and see what the requirements are in NFPA 79. And to do that, I'm just going to open it up at the beginning here. And I take a look, and gosh, there are 19 different chapters. So I'm just going to kind of give you an overview of that information today. There's no way that we can go through all of the information. This standard is about 100 pages long. It was first developed back in the 1960s. It's obviously been revised quite a bit since then, typically every 3 years. So we're going to go through and do an overview of the information. If you need to apply the NFPA 79 standard, you need the standard. You need to open it up and look at it. You need to look at all, not just the general rules we're going to talk about today, but you need to look at all of those subsections, the exceptions, and so forth to make sure that you're in full compliance. All righty, but let's see what kind of information is in this NFPA 79. So I've got 19 chapters and informative annexes A through K. And you should be familiar with that terminology if you're familiar with the NFPA codes and standards. If not, another good reason to go to the NFPA website, right? And familiarize yourself with the formatting of our NFPA standards. Let's talk about the scope and the purpose of this document. What does it apply to? It says this standard applies to the electrical equipment, apparatus, and so forth, less than 1,000 volts, okay? Well, 1,000 volts or less. So we think of a lot of our industrial machinery, 480 volts, 600 volts, and so forth. It covers from the point of connection to the supply to the electrical equipment of the machine. So in other words, if this disconnect, we're supplying our machine, yes, the National Electrical Code applies all the way into the disconnect. Then there are certain provisions for this disconnect, if it's being used on a piece of industrial machinery, that NFPA 79 is going to apply then from the disconnect on into our electrical equipment. Then, so we're going to talk about some of those requirements. The purpose, that's interesting, right? That's very important to us. What's the purpose of NFPA 79? Let's see, I bet you can already guess if you're familiar with NFPA standards then. The standard provides detailed information, well, that's good to know, for the application of electrical and electronic equipment, apparatus or system supplied as part of industrial machines that will promote safety to life and property. So in a nutshell, what's the purpose of this document? To promote safety to life and property. Now, you and I understand what an industrial electrical machine is. We're going to go through and I'm going to review a couple of terms out of the definition, though, just to make sure that we're all synced up and on the same page. Let's look at chapter 3 is where you'll find it, if you happen to have a copy of the book with you. And it's section 3.3.61 and it's definitions. So let's see what they tell us an industrial machine is, see if we understand it properly. It says it's a power-driven machine, or it could be a group of machines grouped together, right? And you could consider that one machine is what they're saying. And it's not portable, can't be portable. We're not talking about any portable equipment then. It's used to process material by cutting, forming, pressure, electrical, thermal, optical techniques, lamination, or a combination of these processes. And it can include a whole bunch of associated equipment as well. Okay? Associated equipment, including the logic controllers, PLC in other words, their software, or logic together with the machine and sensors are considered as part of the industrial machine then. So we're talking about what? We're talking about machines out there that we use everything to, make everything from aluminum to steel or automobile parts to, I don't know, wheelbarrow tires, everything from chemical refining to clothing manufacturing, right? All of those different machines and components out there, a lot of automation equipment and so forth. And we've got to keep people and property safe. We certainly don't want fires to erupt. So we're going to talk a little bit about overcurrent protection. We certainly want to keep people safe, whether they are the operators of the machine or just people who are working in the area doing some other type of work. So everybody's got to be safe, right? Now, let's begin by talking about then chapter 5, actually, where it starts to go into the disconnecting means. Now, we can have different types of disconnects. This is our standard old disconnect you've seen used in other tech talks. It's a 3-pole. I've got 3 fuses on the inside, so it's a fuse disconnect, and it's rated for 600 volts. So a disconnect like this, we would see maybe on the outside or top of an industrial machine. There are requirements for that as to where we're going to place it. Now, another thing is that it may not be a disconnect switch like this. Perhaps we walk up to the machine and all we see is the handle. All of the internals, not the enclosure itself, but the internal, the switch and the fuses are actually on the inside of the enclosure. So we may open up a 3 or 4 foot wide door, 7 foot tall, the handle's on the outside of the machine, but the switching mechanism and the fuses are on the inside. May not be a switching mechanism and fuses. It could be a molded case circuit breaker quite often. And when we operate the handle on the outside, we're operating through a mechanism. We're actually operating the handle on the circuit breaker to open and close it. Now, obviously, this needs to be capable of being locked in the open position so that when we're going to work on the machine, we can do our electrical lockout and tagout, create that electrically safe work condition, right? We've got to simultaneously disconnect all the ungrounded conductors, which is, of course, is what the 3-pole switch would do. It has to be operable by qualified persons. Now, qualified persons, right? Somebody who's demonstrated their skills and knowledge on the construction and operation of the equipment. They understand the safety hazards that are involved. They know how to recognize them, and they've been trained on how to mitigate or prevent from being hurt then. So that's what a qualified person is. So I can have a qualified operator, most likely, who's going to operate this disconnect switch out on the plant floor, not necessarily an electrician then. Now, they always, no matter what the position, we'll close the door, we'll throw the handle to the up position. We now got power to our industrial machine. I can obviously throw the handle, open the disconnect, or if the handle's in the up position, I can go ahead and override the interlock, open the door, and even with the door open, so let's say I'm doing some troubleshooting, something goes wrong, I still have to be able for that machine to throw that handle down and shut the power off. So that's a requirement. As far as the sizing of the disconnect for an industrial machine, 115% of the sum of the full load currents on the machine then. So we size our disconnect at 115%, whatever the full load current is on the machine. Now, let's talk about the protection from electrical hazards then. First of all, 50 volts and greater. That's always our key, isn't it? 50 volts and greater must be guarded against contact, and that can be either by the insulation or obviously the enclosure itself. Now, we have interlocks that prevent from opening the door, right? Except for qualified persons. So if I'm a qualified person, so if my disconnect is in the on position and I try and open this door right now, I can't do it. It's interlocked, right? I have to override the interlock. If I'm a qualified person, I can do that. When it comes to industrial machines, that interlock could be on the side of a disconnect. It could be on the front door of a machine. It could be a key that I have to use to unlock the door. The bottom line is we don't want this door to come open or be opened by anybody if there's power applied to the machine then. Because remember, one of the requirements is when I pull the handle down, I disconnect all three phases, all the power going into the machine. Now, some of the other requirements for protection from electrical hazards, in addition to interlocks. Insulation, I can use insulation for protection. I can use double insulated components on the inside. Also something called protective extra low voltage. That's 30 volts AC or 60 volts DC. So PELV is this commonly abbreviated, protective extra low voltage we can use inside the machine to help protect from shock protection. Now, we should also remember what 70E tells us, that even though we're less than 50 volts, always look at the source of your power and see what the energy level is. You can be at less than 50 volts and still draw, you can get a shock, you can draw significant arc and so forth, simply because of the amount of energy that's available. Now, something else we have to consider for protection of people is discharge of capacitors by permanently installed means. So in other words, we'll quite often have, in our industrial machinery, we'll quite often have capacitors in there, quite often maybe for power quality issues or something like that inside of a large drive. And so those capacitors need to be discharged. So what the requirement is, we're going to have some permanently installed means to discharge those capacitors. It may be a switch somewhere that we would turn and ground out the system and discharge those capacitors. Obviously, there's got to be some interlocks associated with that. Now, there also has to be some signage on the door of that machine to tell us that, caution, do not open for 2 minutes or something like that after shutting power off. And that allows those capacitors time to discharge them. I'll also mention something else that we hear terminology out in the field. People say, well, it's finger safe, it's finger safe. You won't find a definition for finger safe in NFPA 79. You will find information in Chapter 6 then on this mechanical finger that has certain dimensions on it, where they take part of the design then is they take this mechanical finger and they try it on different holes on the machine and on the inside and holes, whatever, and they try and get this mechanical finger through and want to make sure that they cannot contact any live parts when they insert that mechanical finger. And there, all the dimensions are specified for it and so forth in Chapter 6 then of NFPA 79. Now, protection of the equipment and itself is pretty straightforward. We've got to protect against short circuits and ground faults. So, you know, protecting the machine, we've got what? This is some Article 240 stuff, isn't it, from the National Electrical Code, over current protections. Fuses and circuit breakers protect against short circuits and ground faults. So we'll use those to protect our machines. Overloads is what we use to protect our motors from when they draw a little bit too much current and start to overheat on us. Now, over voltages also, Chapter 7 says we have to protect against. So that's surge protection for us as well. Abnormal temperatures, so we'll have high temperature alarms, high temperature shutdowns, and so forth. If I lose the supply voltage, I want an alarm. If I have a type of machine that operates at a certain speed, maybe quite often high speed, I want some overspeed protection as well. So that can be both electrical and mechanical type of overspeeds. Also, if I have incorrect phase sequence for some reason, I've changed something else or put in a new disconnect or whatever, and if I have reverse phase going into that machine, and if that could cause some physical damage or harm to someone, I'm required to have some protection to prevent the machine from being energized and alerting me that I in fact have incorrect phase sequence. So that's the type of information for protection of equipment that we find in Chapter 7 then. Now, grounding and bonding is always important, isn't it? So we're going to ground and bond our equipment for whatever the manufacturer tells us. Now, we certainly, our supply power coming into the top of our disconnect, we followed all the requirements of 250 and Article 250 and so forth for grounding, bonding, and whatever else applies to my installation. When I get to the machine, there are specific requirements in the machine for grounding and bonding. So if you're installing that machine, you may have to go in there and ground and bond that machine. Now, you'll find that the requirements are that we have the symbol for grounding in there, that what UL calls the inverted Christmas tree. You'll see color coding, and it'll be obvious where your ground wires are supposed to connect to, but you want to make sure you follow all the rules, whatever they are then. And the same is true for bonding all of our non-carrying current metal components together. Also, something else not uncommon to run into on industrial machinery is auxiliary ground rods, where we're going to take and not ground the electrical system, but we're going to ground that piece of equipment at the equipment. So if the manufacturer requires that, you'll find requirements in both the NFPA 70E and in NFPA, or excuse me, the NFPA 70, the National Electrical Code, and NFPA 79 for industrial machinery. Control circuits. Here's what we want to do inside of that industrial machine. When I operate this disconnect, I also want to turn off and on the control power. So that means I'm going to have a control power transformer on the inside of my machine. That's preferable. That's what I want to do. Interlocks, once again, prevent unsafe operation. Indications have to be provided for our control circuits, like start and stop, and even the location of the start and stops push button and so forth. All of my permissives have to be met before I can start the machine. So even though I close the door, turn on the power, I go over to hit the start push button, I can't do it unless I meet all of the permissives, meaning all of the requirements in my schematic diagram or my PLC software that would allow me to start that machine, such as, let's say I have an injection molding machine. So I've got these two big, huge pieces of steel, one stationary, maybe 2 to 4 inches thick or whatever. I got another 4-inch piece of steel over here, and there's a mold in the middle. And I'm going to take in with maybe 10 or 20 tons of force or whatever it is, a lot more than that, I'm going to slam those two pieces of steel together. But there's a door right here that I can open up and go in and make adjustments and do troubleshooting or clean out the mold, whatever the operator needs to do. So there better be an interlock that says that door has to be shut before I can start that machine and close that clamp. So that's part of the requirements in. All of my interlock permissives, as we call them, must be met to allow me to start a piece of equipment, as well as, it's pretty obvious too, I have to have emergency stops. And you think about the red emergency stop push button, right? So wherever we need to around that machine, we have emergency stops. Now, when I push that emergency stop in, that big red mushroom head, it stays in, it doesn't come back out. It keeps the contacts open that are preventing my machine from running. Therefore, in order to close those contacts, I've got to go back up to that stop push button, rotate it, I don't know, what is it, quarter, half a turn or whatever, and allow it to pop back out. And that's so that I have to stop and think. I mean, if somebody's pushed an emergency stop, I just don't hit an electrical reset button and start everything again. I have to go out and walk off and go look and see at that emergency stop. I have to go find it and see what's going on and physically reset it. So hopefully that's going to make me think a lot more and make sure that I'm following all my safety requirements before I restart that machine then. So control circuits are very important. A lot of information then in Chapter 9 on control circuits, but that gives you an idea of what you run into. So anyway, in a nutshell, that is NFPA 79. Gives you an idea of the requirements in NFPA 79. And remember, it's for protection of people and property. It's to keep you, the workers, the electrical workers, the operators, everybody out there safe, to keep your equipment safe and your facilities safe. That's why we comply with NFPA 79 then for industrial machinery. So make sure that if you have to apply it, don't rely on the general information today. Go to the code and standard, or excuse me, to the standard and to the National Electrical Code as you need to, and follow the requirements in NFPA 79 and the NEC, okay? Then when you got to work on it, follow the requirements of NFPA 70E as well. Maintain it because you know this, it's electromechanical equipment, right? And if you don't maintain it, it's not going to work forever. And if it doesn't work properly, it's not safe anymore. So you're going to have to rely on NFPA 70B for that. Now, another tech talk coming up in the near term is going to be on NFPA 70B, which is changing drastically this year. So we'll go over NFPA 70B. All righty. So that's it for today. Make sure you go out of here and work safely. This series of Tech Talk videos is brought to you by EC&M Magazine once again, and they're part of the portfolio of Endeavor Business Publications. Make sure you go and sign up for that premium web content if you haven't already, and go out there, work safely, keep yourselves and others safe, right? Until next time, I'm Randy Barnett. We'll see you then.